This is the second in a series of inequality videos. This one is going to be on graphing. So if you need to know the definition or the symbols that we use, so if you don't recognize any of these symbols, go back and look at the video that's on inequality definition and introduction. So I'm assuming you already know what those symbols mean when we get to this graphing one. So we're going to look at this going through particular steps. So if we look at our example, x is less than or equal to 2. We can follow these graphing steps. Now these steps will make it work every single time. There are some other ways to be taught how to graph these that only work if the variable is first, but this method works in any situation. So the first thing we do is find the critical value. Now the critical value just means what is the only number there? So in our example, the only number that we have here is the x is less than or equal to 2. The only number there is 2. So we take our only number, and that's going to be 2. Then we make our number line. This is our step number 2. So when we make the number line, we're going to include the critical value, so that would be 2, and figure out the orientation. To the left of that 2 is 0. So we are going to always include 0 and that critical value. You can add more. You can put 1 in, you can put 3, 4, and 5, but at the very minimum, have the 0 and the critical value. Next thing we're going to look at are the symbols. Now, if we have a greater than or a less than, we're going to use an open dot at the critical value. Now, what that means is that the critical value is not included in your solution. If you remember from our definition, 2 is less than or equal to 2 would be true, whereas 2 is less than 2 is false. So the open dot and closed dot just indicates whether 2 is a solution or not. So in our situation, we have less than or equal to, which means the critical value is included, and we're going to place this at the 2. Now I put mine above just so I can still see all the numbers and I see where everything is. You're welcome to put it on the number line. The next thing we're going to do is we're going to test. I like to test 0. So as long as 0 is not your critical value, we can set the x equal to 0. So we get 0 is less than or equal to 2. And then we decide whether that's true or not. 0 is smaller than 2. So that makes this true. And I'm going to put a little note here that shows me that I tested the 0 and I got true. And then I'm going to draw my arrow towards the true, away from the false. So that means my arrow goes this way. And what this indicates is all of these numbers over here, and it keeps going. That's what the arrow is indicating. It keeps going this direction. So what that means is that all of these numbers are less than or equal to 2. So we've got 1 here, 0, -1, -2, etc. All these numbers underneath this arrow make this true. If we take it on the other side, we've got 3, we have 4, and we've got everything over there. These numbers are all false over here. They don't make this statement true. So my solutions are going to be all of these numbers indicated by the arrow. Let's take a look at another example. So 4 is greater than n. Now I know some of you might have been taught to draw the arrow in the direction of the inequality sign. The only problem with that is it only works if the variable is first. Following it with this method It doesn't matter where your variable is. So you don't have to turn this around so that the n comes first. So we find our critical value. So our critical value is the only number that's there. That would be a 4. So that's my critical value. I'm going to draw my arrow. I'm going to draw my number line. I'm going to include 0 and my critical value of 4. Then I look at the symbols. I've got a greater than symbol. That means that 4 is not included in the solution. So I would use an open dot in this situation. Now I'm going to test a value. So in this case, I'm going to test 0. 4 is greater than 0. That's true. Now 0 was the number I tested. So I've got the T here at the 0. And my arrow goes towards the true. And again, what this indicates is all of these numbers underneath the arrow indicate solutions to this inequality. Let's look at our next example. That's a mess. Let's try it this way. There we go. So P is greater than -1. Again, my critical value is going to be the only number that's there. That number is -1. I'm going to make my number line. I'm going to include my -1. Now -1 is to the left of the 0. So I would include the 0 and the -1. You can include more, but at the very least have that -1 and 0. So looking at my symbols, this is a greater than sign. It means that -1 is not one of my solutions. I need to use an open dot. Now again, I'm going to test a number. Again, I like to test 0. So if I set P equal to 0, 0 is greater than -1. This is true. 0 is bigger than any negative number. So I would have a T for true at the 0 and draw the arrow through the T. And that indicates that all of these numbers here are solutions to this inequality. I think we've got one more example out here. So 0 is less than or equal to z. So what happens when our critical value, which is the only number here, so we've got 0. I'm going to draw my number line, include my critical value, 0. And just so we have some orientation, pick another number to include. So I'm going to pick 5 there. I would have -5 on this side. Now I look at my symbol. I've got less than or equal to, which means that I'm going to use this solid dot. I'm going to set my z equal to -5 and test the -5. So 0 is less than or equal to -5. Now this is not true. Not true. 0 is not less than -5. 0 is bigger than -5. So this side would be false. Now remember, I'm going to arrow away from the false, which means I'm going to draw my arrow this direction. And that shows me how to graph inequalities. Next video, we will be looking at how to find the inequality given a graph. So keep an eye out for that one.